Hello and welcome. We're really glad you joined us. This tutorial will help you understand areas, topsoil regions, calculations, and results in SiteWorx OS version 8. Now that the 3D surface model is created from the elevation points, the next step is to place the various areas onto the surface model. Our tutorial, Takeoff tab, covers elevation points. Before digitizing areas, make sure you select Options, Show Properties/Elevations dialog to turn it on. Let's isolate the slab layer and the parking area. Since this is a vector file, it's a good practice to select Snap to the Entity Point when recording the areas. When you click the first corner of the area elevation properties dialog is displayed, because earlier the Show Properties/Elevation dialog was turned on. The area type is important. Flat areas, like this slab on grade, are surface areas. The surface area is placed on top of the surface model at the elevation recorded. A contour line is also recorded around the perimeter of a surface area, so that the points in the perimeter of the surface area will slope to the next closest points outside the area. All building pads at grade should be defined as surface areas. Subgrade only areas are used for all non-flat areas where the elevations are reduced by the subgrade material depths assigned to the area. In this example, the parking area is defined as subgrade only area. The basement area type is used for flat areas either above or below grade where the walls are straight. A contour line is not recorded around the perimeter of a basement area. The perimeter of walls of a basement are vertical and do not slope to the next closest elevation points like they do in a surface area. In Other area type is used to calculate the area and perimeter length of an area. An other area type has no effect on the surface model or the cut and fill volumes. On the Area Elevation Properties dialog, enter the top of finished floor elevation. Select the area type, in this case surface. The overcut value enlarges the size of the area by a positive value. For example, you may excavate over a larger area for formwork or placement of select fill. Enter 4 in feet to place select fill over this overcut area. Enter 0.33 feet above grade, as the slab will sit above the proposed grades. Often this value is set to 0. It's good practice to color code the areas, assign an area fill pattern, and name or identify the area. When done digitizing around the perimeter, stop the takeoff, and then enter the material layers information at the Layers tab. In this example, the proposed soil elevation is reduced by the concrete thickness and by the depth of the select fill. To do that, record the layers. Concrete, 0.5 feet. Select fill, 2 feet. By checking Overcut, the select fill layer is applied to the overcut area. Thus, the true soil elevation will be 2.5 feet below the top of the finished floor elevation. The parking lot area is recorded in a similar way. Areas that are not flat or level are usually defined as subgrade only type areas, where an elevation is not required. The layer depths entered at the Layers tab will reduce the elevation points previously recorded in this area. Color code the area, enter a fill pattern, and name the area. In this example, the elevation points around the parking lot were recorded as top of curb elevation points. Enter the layers information. The elevation of the parking lot must be reduced by the curb height and then by the pavement thickness to arrive at top of soil elevations. After recording the parking areas, select Yes to copy the layers from the last area recorded. The planter island is eliminated by clicking the negative checkbox. The project requires topsoil strip and respread volumes. The topsoil strip and the respread regions are recorded at the appropriate selection. In this project, the entire project boundary will be stripped of topsoil. Select the project boundary, then right-click the mouse and select Copy as Topsoil Strip. Also, copy the project boundary as Topsoil Respread Region, and then exclude the previously recorded areas. To eliminate the building slab and parking area as a topsoil region, select these areas at the Area Elevation. Then, copy these areas as excluded topsoil respread regions. The planter island is copied as an included topsoil respread region. Display these included and excluded topsoil regions by choosing the Topsoil Respread selection. After recording the project boundary, elevation points, areas, and topsoil regions, the next step is calculating the project. Click on the Calculations tab. Enter topsoil waste or the percentage of organic material pertaining to the topsoil. Record the swell factors for the topsoil. Define the swell factors for the subsoil when borings are not used. Note that values are reported by grid box. Define the size of the grid box. Click View, Takeoff Grid to view the grid boxes at the Takeoff tab. When calculating the results, the defined grid boxes are further divided into squares. The number of squares per grid box is defined by the resolution setting. The higher the resolution, the more calculations are performed to calculate the results. As you can see, the calculation resolution changes as the resolution increases. Normally, start at medium or low resolution. Review the results and the 3D model. For final numbers, increase the resolution setting or decrease the grid size. At high resolution with a 50-foot grid, the existing and proposed elevations are calculated every 12 inches and every 2 feet when the resolution is set to medium. Simply click Calculate to calculate the project. The left column shows the calculated volumes before swell factors. The calculated loose volumes after applying the swell factors are in the right column. The required site balancing adjustment is shown at the bottom. The calculated information is broken out into topsoil volumes and subsoil volumes, and into cut and fill volumes. Many professionals use Microsoft Excel to price or estimate the cost of the quantities. Click Copy to Clipboard to simply copy these calculations to your clipboard. Then you can paste the information into an Excel workbook for pricing. As we move from left to right along the tabs, additional information is provided. The 3D View tab is where the 3D models are displayed. Here, the existing elevations are displayed, and the proposed elevations. And the cut and fills are displayed in a plan view without the mesh. The Cross Sections tab displays the existing and proposed elevations at each grid box. The Grid Data tab displays information for each grid. Each grid has a reference address. The Grid Data tab gives the cut and fill volumes for each grid box and the cut and fill depths at the corners of the grid box. A value of OB indicates that particular corner is found outside the project boundary. Two different displays are available at the Grid Data tab, Cut/Fill and Stakeout. The Stakeout view shows the existing and proposed elevations, along with the cut and fill depths at the northwest corner of each grid box. Click the Export button to export the information at the Grid Data tab into a variety of file formats. Click the GPS button to create an ASCII comma delimited file showing locations and the cut and fill depths at each location. At the Reports menu, a variety of reports are available to document the project. Please review the various reports. The Area Layers report, for example, reports the area and perimeter of each digitized area, and it shows the volume of the subgrade materials found under the area and the cut and fill volumes. Thanks for joining us for this tutorial about areas, topsoil regions, calculations, and results in SiteWorx OS version 8. And of course, please contact us if you need further help. We're eager to be of assistance to you.